One of the flawless structures in the brain is the glial cells that assist the neurons. Glial cells are made up of fibers that permit them to act much faster than neurons. We can compare these fibers to a highway, which the neurons proceed down. Through this highway, the neurons proceed to the correct address in a convoy. This traffic never becomes snarled up, and there are never any accidents, because every neuron sets out in perfect order, using the information encoded within it at the right time and in the right manner. This journey undertaken by the neurons is literally like a migration. The neurons that reach the outside of the spinal column now begin forming layers and establishing the brain.
You can think about development like a play that follows a script that is written down by the genetic code, but it has no director, it has no producer, and it has a bunch of actors that have never spoken their lines before. Despite all this, you pulled the play off. To me, that's a miracle.
Once the baby has spent 6 months in its mother's womb, almost all its organs have taken shape. Its hands, nose, heart, and brain. Brain growth is very fast in this period. The number of neurons in the brain has reached 100 billion. Trillions of connections are established between them, and the number of these connections continue to grow non-stop throughout life. Science is still unable to explain how these connections are established. The electric currents that form between the neurons permit uninterrupted communication between the brain and body. This is the moment when the baby first opens its eyes to the world. A long period of learning now awaits it. The baby will learn how to use its eyes, ears, and feet. At the same time, it will develop the ability to speak and think, which Allah bestows on human beings alone. To that end, it will make use of the nerve cells that constantly multiply and establish connections between them during its 9 months in the mother's womb. The sense of smell is one of the first to develop. That is how a 2-day-old baby recognizes its mother. The last sense to develop is sight. The world is not at all clear to the eyes of a newborn baby. The baby only begins to see its surroundings like an adult when it is 6 months old. It can now follow moving objects and perceive depth. The neurons constantly store information during the baby's maturation. The brain of an 11-month-old baby is now mature enough to distinguish culture and spoken language. Some neuron networks are used more than others during this process. Some of these networks grow strong and multiply, while those that are not used disappear. How does the nervous system that is far more complex than all the computers in the world actually work? The nervous system consists of some 100 billions of neurons, and the trillions of connections between them. Let us try to imagine what trillions of networks really means. Imagine you are exchanging messages with a friend over the internet. Then another friend joins in. Now let us expand on that a bit. All the 16 million people living in Istanbul are exchanging internet messages with one another at the same time. And imagine that all this traffic is intended to serve a common purpose. and let this communication continue uninterrupted for a whole lifetime. Now let us increase the number of cities to 62,000. Let us now try to envisage a network made up of 62,000 cities the size of Istanbul, all in constant communication with one another. That is the brain. The nervous system is divided into two parts, the peripheral and the central nervous system. The peripheral nervous system transmits information obtained from everywhere in the body to the brain at an enormously high speed. The 1 billion or so neurons that make up the spinal column are charged with this task. The neurons that surround every point of the body, the arms, legs, and internal organs, in such a way as to establish a communication network, establish a link between the brain and the body. The nerves that extend to everywhere in our bodies enable the whole body to function in harmony and to maintain its equilibrium. The central nervous system, on the other hand, is a highly complex command center in which all the data arriving from the body are analyzed and where decisions are taken in the light of that information. There are some 85 billion neurons in the central nervous system. The brain, the most important component of this system, constitutes just 2% of the body's mass, and billions of neurons have been created such as to fit into this small and confined organ. The main workers in the system are microscopic cells, just 1/200th of a millimeter in size. When these combine together, they permit the operation of the brain, many of whose function are still a mystery. And most important of all, it is merely a group of cells, not conscious human beings, that make up this glorious communication network. There are antennae known as dendrites on the brain cell membranes that perceive the messages reaching them. The antennae are connected to a main body at one end, and at the other end of that body is a switchboard, the axon, that disseminates information at the other end. The shape of neurons depends on where they are and what they do. For example, the axon that will transmit a message from the spinal column to the arm is 1 meter long, while another axon stretching from the eye to the brain is just 5 centimeters long. The information collected by millions of neurons to the sense organs is transmitted to the brain at an amazing speed. Just 1/50th of a second. They use electrical and chemical signals in doing this. There may be between 100 and 10,000 antennae in a brain cell. This number rises or falls according to requirements. The antennae catch the information coming from the cell and send it to the switchboard at the other end. The switchboard or the axon end has sacs for distributing information. These are all full of neurotransmitters that convert the electrical signal into a chemical one. Two neurons are separated by a synaptic gap. This space you are looking at now is in fact just 1/50th of a millimeter in size. The neurotransmitters jump across these gaps from one cell to another and enable communication between the two cells. There are receivers at one end of the cell and transmitters at the other. The neurotransmitters at the transmitter end are stimulated by an electrical signal, and with that signal, a molecular flow or bombardment start from the axon end. The other cell surface is covered with receivers in a manner very reminiscent of a tulip. When the molecules arrive here, the receiver leaves open and permits the molecules to enter inside. There is a single door for each molecule to enter by. The molecule and door it will enter by have been created to fit one another, like a lock and key, and no transmitter can enter by a door belonging to any other. The molecules set up a new electric current in receiver cells. The information has been transmitted to the other cell, and the neurotransmitter's work is finished. The molecules whose work is finished return to their own nerve cells by a special door belonging to their own type, and that different neurotransmitters can never use. Neurons need to be nourished if they are to perform all their functions in a perfect manner. Brain cells are nourished with just pure glucose and water. If the oxygen needed does not reach the neurons, the transmission of data is interrupted. Because glucose, the neuron's fuel, can only become usable in the presence of sufficient oxygen. The sugar cannot be used when there is insufficient oxygen. In such an event, information is either stored slowly or not at all, and that can be described slow perception or being quick to forget. The neurons are not alone in the nervous system. Glial cells are charged with supporting and protecting the brain cells. In terms of mass, half the brain consists of glial cells. Since these are much smaller than brain cells, their numbers are 10 times greater. Some glial cells help with the nourishing of the neurons. Others form a sheath known as myelin around the axons. This sheath increases conductivity at the endpoints as it isolates the lateral surfaces of the axons transmitting electrical signals. In other words, information is transmitted to the neurons at great speed and with little loss. Following the same logic, all present-day communications equipment and medical devices use specially insulated fiber cables to increase speed and minimize loss. The aim is to seek to reduce data transfer duration with the help of these cables. The discovery of fiber cables is of great importance in the spread and speed of technology. But when we look at the human body, all the details have been considered and installed in exactly the right places, while it is still in its mother's womb. In exactly the same way that the myelin sheath is created only around cerebral neurons, just where it needs to be, in the most perfect form. One group of glial cells are responsible for protecting the nervous system against foreign bodies and microorganisms. The cells in this group surround foreign bodies and literally digest them. What we have touched on so far is too little to be even considered a simple summary of the brain functions that we know about. And what scientists today do know about the brain is just the tip of the iceberg. The brain has a most complex and sublime structure. It is clearly a miracle of creation, and it is irrational, in a word, for man, on whom such an extraordinary organ has been bestowed, to depict this structure as the work of chance, or to seek to explain it in terms of the theory of evolution. This is how the Quran refers to people who deny Allah, our Creator, by falling prey to this irrational belief. I seek refuge in Allah from the accursed Satan. Does not man see that we created him from a drop? Yet there he is, an open antagonist. He makes likeness of us, and forgets his own creation, saying, "Who will give life to bones when they are decayed?" Say, he who made them in the first place will bring them back to life. He has total knowledge of each created thing.